If we want to measure the diameter of a metal wire or the thickness of the paper, how thin is the paper, we can use a micrometer for measurement. The structure of a micrometer is simple. It's basically divided into three parts, the first being this opening where we put the portion that we would like to measure. The second part is this turnable button with a scale illustrated right here. Pay attention to the scale, 0, 5, 10 millimeters, and in between 0 to 5 millimeters, it is divided into 10 marks. Each mark represents 1 millimeter. While we wind up this button for one turn from 0 to 0, it actually involves one small mark, which represents 0.5 millimeters in the scale. For the turnable scale, there are 50 marks in total, so the smallest scale then represents 0.5 divided by 50, that is 0.01 millimeters. Now we try to measure the diameter of this metal wire. Reduce the width of this opening, wind up the large button, and then place the metal wire in between the gap and wind up the button until it is tight. We then wind up the small button until the sound tack tack is heard. Lock the position and we can take the reading now. The reading on the upper scale is approximately 0.5. With reference to the turnable scale, the reading is 3 marks more than 45, that is 48, so the result is 0.48 millimeters. To measure the thickness of this paper, we insert it into the opening gap, then wind up the button until we hear the tack-tack sound. We lock on the position and we observe that the thickness of the paper reads less than 1 mark in scale, which implies that the thickness is less than 0.5 millimeters, and the turnable scale reading is 11, that is 0.11 millimeters. What is the reading here? By observation, the final reading is approximately 11.5 in scale. The turnable scale reads approximately 20 in scale. It implies that the actual reading is around 20 to 20.5. By adding 0.205 to 11.5, the result is then 11.705 millimeters. Let's try another one. What is the reading here? It is 6.35 millimeters. As we mentioned before, to observe the minimum reading, we should take reference to the circular scale. Divide 0.5 millimeters by 50. So the minimum scale is 0.01 millimeters, and the scale uncertainty, or reading error, is 0.01 divided by 2. That is 0.005 millimeters. When these two parts are closely aligned with each other at the decimal place, the reading is exactly 0, which implies that there is no set zero error. That is, no error exists at the decimal place. Only one reading error results. The reading error equals half of the minimum scale, that is 0.005 millimeters. We should wind up the large button until the gap between the micrometer and the object for measurement is tight enough. For fine-tuning the measurement, we should wind up the small button until we hear a tack-tack sound.